Hello students. In this video, we'll study about solution of homogeneous and non-homogeneous differential equations of higher order. Before we take up the examples, we'll understand what we mean by homogeneous and non-homogeneous higher order differential equation. Any equation of the form f of d of y is equal to phi of x. Then if phi of x is equal to 0, then the equation is called homogeneous. Otherwise, it is called as the non-homogeneous differential equation. Now, in this video, we'll find the solution of one of the type of the non-homogeneous equations where phi of x is equal to e raised to ax. Now, let us take an example with a homogeneous differential equation of fourth order. Here, the given differential equation is 4d raised to 4 minus 8 d cube minus 7d square plus 11d plus 6 is equal to 0. Now, when a differential equation is given, the auxiliary equation of the differential equation, in short, we write it as AE, which is an auxiliary equation, is obtained by replacing d by m. So it is 4m raised to 4 minus 8m cube minus 7m square plus 11m plus 6 is equal to 0. So this equation is called as the auxiliary equation. We have to find the roots of this equation and we'll write the complementary function. The solution of the homogeneous equation is called as the complementary function. The roots of the biquadratic equation, we'll find it by synthetic division method. So what is this synthetic division is? We have to write the coefficients of this equation in a order. That is, see that if the given equation is in the standard form. So here the given equation is in the standard form. Write the coefficient 4 minus 8 minus 7 11 and 6. Find the value of m for which this equation is satisfied. Note that if I put m equal to 0, we'll get plus 6. So that means that 0 is not the root of the equation. So go for substituting m is equal to 1. Again we'll see that it is not equal to 0. And go for verifying for m equal to minus 1. If I take m is equal to minus 1, then this equation, it is minus 4 plus 8 minus 7 minus 11 plus 6, we'll get it as 0. That means that minus 1 is one of the roots. So that is minus 1. For the by synthetic division method, so what we have to do it is, one of the root you find it by the trial and error method. The first term what we have, repeat here. So it is a 4. Now multiply this minus 1 with the 4 and write it here. So minus 1 into 4 is minus 4. Write it below the minus 8. So in addition, it is minus 12. Now minus 1 into minus 12. Repeat the same thing. It is 12. 12 minus 7 is plus 5. Minus 5 into plus 5 into minus 1 is minus 5. We have plus 6 here. So minus 1 into 6 is minus 6, which will get it as 0. So if you have taken the root as correct here, then definitely the last equation will be equal to 0. So this is the minus 1 is one of the root of the equation. Now similarly, this equation, you find it one more root by the trial and error method, or else this equation will be an cubic equation. It is 4m cube minus 12m square plus 5m plus 6 equal to 0. In the calculators, you can go for finding the roots of this equation and write the remaining 3 roots directly. Or else, we can also have one more step in the synthetic division. So find one more value which will satisfy this equation. So we see that if I put m equal to 2, the m equal to 2 satisfies the equation. So again repeating the synthetic division method, it is, we'll write 4 as it is here. So 4 into 2, it's 8. So minus 12 plus 8 is minus 4. And then minus 4 into 2, it's minus 8. 5 minus 8 is minus 3. Minus 3 into 2 is minus 6. So we have the two roots, minus 1 and 2. And this equation is a quadratic equation. 4m square minus 4m minus 3 is equal to 0. So we'll find the roots of this quadratic equation. It is 4m square minus 4m minus 3 is equal to 0. So 4 into 3 is 12. Factorize 12 so that we'll get minus 4. So it will be 6 2s are 12 and 6 minus 2 is 4. So minus 6m plus 2m minus 3 equal to 0. 2m is common. It is 2m minus 3. Here 1 is common. We have 2m minus 3 equal to 0. So the roots are 2m minus 3, 2m plus 1 equal to 0. So we have the values of m as 3 by 2 and m is equal to minus 1 by 2. So the roots of the biquadratic equation are, it is minus 1, 2, 3 by 2 minus 1 by 2. Note that all the roots of this equation are non-repeated roots. So the complementary function for the non-repeated roots, that is given by, so we will denote the complementary function as yc, and it is given by every root we have to take it with the arbitrary constant. So here I will take c1 e raised to minus x plus c2 e raised to 2x plus c3 e raised to plus 3 by 2x plus c4 e raised to minus 1 by 2x. So in case of the roots of the quadratic equation or the cubic equation, depending on the nature of the roots, we have a different type of the solutions, and this is the solution corresponding to non-repeated root, that is for the distinct roots. One more point to be noted is that in the calculators of higher configuration, we can get the roots of the equation up to cubic order directly. So in the calculators, we need to go for the mode and then go to the equations. In that, choose the degree as 3 and enter the coefficients. Enter the coefficients, we'll get the values of these roots directly. So in the calculator, we can maximum do up to degree 3. But if the fourth order is given, we must have to do at least one root by using the synthetic division method. So this is the solution corresponding to an homogeneous equation, where for the homogeneous equation we'll get only the complementary function. For the non-homogeneous functions, in addition to complementary function, we'll have one more solution which is called as the particular integral. So depending on what is phi of x, we have a different methods of finding the complementary function. So we'll take up with the first type of the non-homogeneous equation when the right hand side of the function is given with e raised to x. So suppose that this is the given problem. You note that the right hand side of the function is e raised to 2x. So it is of the form f of d of y is equal to e raised to ax. So here first we need to find out the complementary function as it is how we did it in the non-homogeneous equation, and then with respect to this right hand side function we'll find the particular integral. And the general solution of this differential equation will be a complementary function plus the particular integral. The particular integral is denoted by yp. So write this given differential equation as with the operator d. So this will be written as d cube minus 5d square plus 7d minus 3 of y is equal to e raised to 2x. The auxiliary equation is m cube minus 5m square plus 7m minus 3 is equal to 0. So we'll find the root of this by either synthetic division method or else, as I said, do it in the calculator directly. Here I am showing with the synthetic division method. It is 1 minus 5 plus 7 minus 3. So take m is equal to a number which will satisfy this equation. Now, if I put m equal to 0, we see that it is minus 3. So, 0 is not the root of the equation. The 0 will be the root if you don't have the constant term in the equation. So, let me check for 1. It is 1 minus 5 plus 7 minus 3, which will be equal to 0. So, that means that 1 is the root of this equation. So, take m equal to 1. Repeat this number 1. 1 into 1. Write it here. It's minus 4. 1 into minus 4 is minus 4. 7 minus 4 is 3. 3 into 1 is 3. So it is 0. So we have a quadratic equation m square minus 4m plus 3 is equal to 0. Do the factorization. It is m square. 3 into 1 is 3. 3 plus 1 is 4. So it is minus m plus 3 is equal to 0. So m minus 3, here minus 1 is common, m minus 3 equal to 0. So m minus 3, m minus 1 equal to 0. So m is 3 and 1. So the roots of this equation are 1, 1 and 3. Note that the 1 and 1 are the repeated roots. So the complementary function will be c1 plus c2x, write e raised to 1x. So for every repeated root, if it is repeated for 2 times, the coefficient of e raised to x will be a polynomial of degree 1. Suppose that it is repeated for 3 times, then the coefficient of e raised to x will be a quadratic polynomial plus e raised to c3 e raised to 3x. So this is the complementary function corresponding to the given differential equation. Now we'll go for finding the particular integral of this. To find any particular integral, so whatever it is there on the right hand side, write the function divided by its differential equation, which is d cube minus 5d square plus 7d minus 3. Now this is called as the type 1 of particular integral. Here we go for substituting or putting the value d is equal to coefficient of x in the exponential function. So here the coefficient of x in the exponential function is 2. So take or put d is equal to 2. So it is e raised to 2x divided by 2 cube minus 5 into 2 square plus 7 into 2 minus 3. On simplification, it is e raised to 2x, 8 minus 20 plus 14 minus 3. So it is e raised to 2x divided by, we'll get this as minus 1. So the particular integral is e raised to 2x, or you can just simply write e raised to minus x. So therefore, the general solution of this differential equation is y is equal to yc plus yp. So where the yc is c1 plus c2x into e raised to x plus c3 e raised to minus 3x plus 3x minus e raised to 2x. Let's take one more example. So this given equation, we'll write it with the operator d. So it is d cube minus 6d square plus 11d minus 6 of y is equal to 2 e raised to 3x plus 3. Write the auxiliary equation. Here this operator d will be d by dx. Write the auxiliary equation. The auxiliary equation is given by m cube minus 6m square plus 11m minus 6 is equal to 0. So find the roots of this by either using the calculator or by the synthetic division. So here I will show it by the synthetic division. At the end of this video, I will show you how to find the roots of the cubic equation in the calculator. It is 1 minus 6, 11 minus 6. Find the value which will satisfy this equation. So here the 0 won't satisfy this equation as we have the constant. Take m is equal to 1. So 1 minus 6 plus 11 minus 6 is equal to 0. So that means that 1 is the root of this equation. So we have one root with the trial and error. Repeat this number 1. 1 into 1. Write it over here, which is 1. So minus 6 plus 1 will be minus 5. Minus 1 into minus 5 plus 1 into minus 5 is minus 5. 11 minus 5 is the 6. And 1 into 6 is the plus 6. Right over here. So it is 0. So we have the quadratic equation m square minus 5m plus 6 is equal to 0. Go for factorizing this. So the factors will be 2 and 3. So it is 2m plus 2m minus 3m plus 6 is equal to 0. m minus 2 and m minus 3 are the roots. So m is equal to 2 and m equal to 3. So the roots of the auxiliary equations are 1, 2, 3. So already we have discussed, for these are the non-repeated roots. So the complementary function corresponding to this non-repeated roots is given by yc is equal to c1 e raised to x plus c2 e raised to 2x plus c3 e raised to 3x. So this is the complementary function for the non-repeated cubic roots. To find the particular integral, so the function on the right hand side is 2 e raised to 3x plus 3 divided by its differential equation, which is d cube minus 6d square plus 11d minus 6. Now separate that. It is 2 e raised to 3x d cube minus 6d square plus 11d minus 6 plus 3 divided by d cube minus 6d square plus 11d minus 6. So for the first term, according to what we have discussed, here we have to put d is equal to the coefficient of exponential x in the exponential function, which is 3. But in the second term, we don't have an exponential function. But if any constant is there, that we can write it as e raised to 0x. So the coefficient of d, in this case, it will be 0. So take 2 e raised to 3x divided by 3 cube minus 6 3 square plus 11 into 3 minus 6 plus 3 into e raised to 0x divided by 0 minus 6 into 0 plus 11 into 0 minus 6 to e raised to 3x. On simplifying this, we see that it is reduces to 0 plus here it will be 3 by minus 6. Now note that in the previous case, we ended up writing yp if the denominator is a 0 number. So in this case, we got it as it is 0. So in such cases, when we get the root after substituting the value of d, if we after substituting d is equal to 3 or d equal to a, the coefficient of x in the exponential function, suppose that if we get the denominator as 0, then what we have to do it is take x on the numerator, it is x e raised to 3x divided by differentiate the equation in the denominator. So here it will be 3d square minus 12d plus 11. The derivative of 11d will be 11 and the derivative of 6 will be 0 minus 1 by 2 here. Now go for taking d equal to 3 once again. So it will be 2x e raised to 3x divided by 3 square minus 12 into 3 plus 11 minus 1 by 2. So that we get it as 2x e raised to 3x. 9 3 is 27 minus 36 plus 11 minus 1 by 2. So here it will be 27, 38 minus 36 will be 2. So it will be 2 e raised to 3x divided by 2. So the 2 get cancelled here and this we have it as minus 1 by 2. So particular integral yp is x e raised to 3x minus 1 by 2. So the general solution is y is equal to yc plus yp, which is in this problem y is equal to c1 e raised to x plus c2 e raised to 2x plus c3 e raised to 3x plus x e raised to 3x minus 1 by 2. So here in this problem we learned that if after substituting d is equal to a, if the denominator reduces to 0, then we need to differentiate the differential equation and take x on the numerator. And suppose that after substitution also, if we get again 0, then this procedure will be repeated. So that usually happens when the coefficient of x is the one of the root. That is, you see that the coefficient of x is 3 here, it is one of the root. Suppose that if it is repeated for 2 times, then we may get this twice as a 0 and the numerator will be x square. Let's go for one more similar kind of the example. So this is the differential equation. Here we have this with the operator d as 3d square 3d plus 2 of y is equal to the sine hyperbolic 2x plus 3 in terms of the exponential I is written as 1 by 2, it is e raised to 2x plus 3 minus e raised to minus minus 2x minus 3. So that will be, here the auxiliary equation is m square plus 3m plus 2 is equal to 0. Find the roots of this equation. The roots of the equation are given by, so factorize 2 so that it will be 1, it will be 3. So we have the roots as m is equal to minus 2 and minus 1. So this is the non-repeated roots. The complementary function is c1 e raised to minus 2x plus c2 e raised to minus x. So this you do it either by the factorization or by the directly in the calculator. Now to find yp, it is 1 by 2 e raised to 2x plus 3 minus e raised to minus 2x plus 3. So here it is plus divided by the differential equation, which is d square plus 3d plus 2. Now we'll separate it. We'll take it as p1 and p2. It is e raised to 2x plus 3 divided by d square plus 3d plus 2 minus e raised to minus 2x plus 3 divided by d square plus 3d plus 2. Now let me take this as p1 and here it is as p2. So the p1 is e raised to 2x plus 3 divided by d square plus 3d plus 2. Now here note that the coefficient of x in the exponential is 2. So take d is equal to 2. It will be e raised to 2x plus 3 divided by 2 square plus 3 into 2 plus 2. So that will get it as 6 plus 2, 8, 8 plus 4 will be 12. So it is e raised to 2x plus 3 divided by 12. So similarly, the P2, it is e raised to minus 2x plus 3 divided by d square plus 3d plus 2. So here the coefficient of x in the exponential is minus 2. So take d equal to minus 2. It is e raised to minus 2x plus 3 divided by minus 2 the whole square, 3 into minus 2 plus 2. So we see that the denominator is 0. So what we do if the denominator is 0, we'll take x in the numerator and differentiate the differential equation in the denominator. So which will be the derivative of d square is 2d plus the derivative of 3d is 3. Now take d is equal to minus 2 again. So that is x e raised to minus 2x plus 3 divided by 2 into minus 2 plus 3. So we have the value of P2 as x e raised to minus 2x plus 3. It's a non-zero number which is minus 1. So therefore your particular integral yp is 1 by 2 e raised to 2x plus 3 minus e raised to minus of 2x plus 3. It is x into divided by minus 1. So here it is divided by 12, the P1 minus P2. Now we'll write the general solution of this. It is the general solution y is equal to yc plus yp, which is c1 e raised to minus x plus c2 c1 e raised to minus 2x c2 e raised to minus x, and the particular integral is 1 by 2 e raised to 2x plus 3 minus, so that we can write it with a plus sign, x e raised to minus of 2x plus 3, and here it is divided by 12. So rewriting this, c1 e raised to minus 2x plus c2 e raised to minus x, take the LCM and multiply. It is 1 by 24 e raised to 2x plus 3 plus 12x e raised to minus of 2x plus 3. So this is the general solution of the given problem. Thanks for watching.